right? So this is our beam written with our x component. We have t sine of 70 pointing up, t sine of 70 pointing up, because they were both 70 degrees and they both have a tension t because they're symmetrical, so these two are the same, and the t cosine of 70 here and the t cosine of 70 here. Now that we have broken up into its parts, we can use our net force equation. So we can say that we can look at the y, because we don't really know anything in the x. We can say that the net force in the y direction is equal to 0, which means that t sine of 70 plus t sine of 70 minus 8,000 has to equal 0. So from here we can even clean up that equation a bit, and we can just move the 8,000 over and say that 8,000 now becomes positive is equal to 2 t sine of 70. Now sine of 70 is an actual number. The actual number is equal to 2 times t to about 0.94 t. That's what sine of 70 is. Sine of 70 is the same as about 0.94. So then we get 8,000 newtons is equal to 1.88 t. And then we divide both sides by 88, 1.88, and we get that t is equal to 4,255 newtons. So our final answer is 4,255 newtons, which is the same answer we got before, just a different way. This way is a little bit longer, but it's a little cleaner and it works more often. Again, the main thing is you just try to break up all the forces into its components, and then you try to create an equation. This is the more algebraic way to solve it. That's it. Okay, here we're going to do chapter 4, page 124, number 50. I showed you the short way. If you did the short way and decided to come look at the long way to solve this problem, good for you, way to be brave. The way you started off is you would draw it the same. We have two tension forces. Oops. So we have a beam that weighs 8,000 newtons and it's being pulled up by two tension forces acting at a 70-degree angle. The way we do this, anytime we have an angle or a force acting at an angle, the best thing to do is to break it up into its x and y components. Now, the tricky part here is that we don't know what the tension is, so it's a little hard to visualize. So if we took this force and broke it up into its x and y component, I'll just simply redraw it. So here we have this tension force, and like any vector, this is going to have an x component pointing this way, and it's going to have a y component pointing up, right? That make up its components. Now, the way we solve for this, even though we don't know what tension is, we can still say that the tension in the y component is equal to whatever the tension is times sine of 70 degrees, just like you did on your worksheet, which means that the x component is equal to 10 cosine 70 degrees. Now I know the x component is negative, but remember the arrow here kind of makes that obvious for us. So we have the blue and the green. So the step into solving this problem is I incorporate that into this actual shape. So I kind of get rid of this tension part here and rewrite it into its x and y component. So it ends up looking something like this.